Now we're going to get into Young's double slit experiment. This diagram is slightly different than the way he did it originally. There is a link to a Veritasium video about Young's double slit experiment on the eLearn site, where he basically goes in and looks at the original equipment. And originally Young did notice this with white light and how the white light came through small gaps in his curtain. So when we set up the actual experiment, this is the description is of the original experiment where you put it through a single slit, and then you get the monochromatic coherent light to come through, and then you can put that monochromatic coherent light through the double slits. So the main experiment is, in fact, these double slits, two slits in a film, and these slits are very, very narrow. They're getting close to the wavelength of the light. So the light waves emerging arrive then at the second slit and then arrive at the screen. So in modern experiments, we use an electron gun for electrons, or we'll use a laser. So here's some images of what is the result. And so same words is that the light goes through these two slits and we get what's called the interference pattern. So this is that same Veritasium video where he's doing the very same thing with water, and you can see places where there is destructive interference and then constructive interference where the waves amplify each other, and it's an alternating pattern that looks like the green area in the middle from above. Then you can see alternating patterns of constructive and destructive interference. And what happens when we put this on the screen is we'll basically get bright areas and dark areas on a screen, and it'll be stripy. So the slits act as two basically sources for the wave. As the light comes through, it basically creates two waves that are in sync with each other and are therefore able to interfere with each other. And so one of the important parameters we're going to look at is the distance between the two slits. We're going to typically give that a parameter d, and it's kind of counterintuitive that as the slits get farther apart, the bands actually get closer together. And when we look at the math in the last section, and actually the equations, we'll basically see how that works. But it's, I think, counterintuitive that as the slits get farther apart, the bands get closer together. So the light from the two rays form this visible pattern on the screen. This has the very not creative word fringe. Basically, think of a fringe on a carpet is these long parallel lines. So constructive interference occurs where we have a bright fringe. So we call that constructive interference, and then destructive interference occurs where we have a dark fringe. And the one thing that we can use this for is basically to determine the wavelength of light. So here you see three different colors, and they all give the same pattern, but you see that the distances are different. So if we can measure the distances of these fringes, right, and the width of these fringes and where all these dark areas are, we can use basically just geometry, some simple geometry to figure out what the wavelength of light is. So what causes this interference? Well, we have constructive interference if the light arrives at the screen in phase. So basically here, if we're traveling two equal distances, so this distance is going to be R1, and this distance is going to be R2, that if those two distances are exactly the same, or if they are one wavelength off, then they're going to arrive in phase and you'll have constructive interference. So, and we get constructive interference not only if they travel exactly the same distance, but if one wave travels one wavelength farther. So this upper wave travels one wavelength farther, so it also arrives in phase. Now we get destructive interference, or dark fringe, when that delta is half of a wavelength different. So we look at this, and this is basically 1.5 wavelengths, so this is off by half of a wavelength. So here we arrive out of phase and we get a dark area because you get one wave that's going up and one wave that's going down, and they destructively interfere with each other.